Hi there, this is section 1.6 video, and it's solving compound and absolute value inequalities. So if we look at what our vocabulary is for this section, we have three vocabularies: compound inequalities, intersection, and union. And in this section, we're going to solve compound inequalities, and we're going to solve absolute value inequalities. So let's first start with defining what is a compound inequality. So compound inequality basically just consists of two inequalities joined by the word and or the word or. Okay, so let's look at what the first compound inequality is. This one uses intersection. That's one of our vocabulary words. And it uses the word and, compound inequalities. So compound inequalities with the word and are true if and only if both of the inequalities are true. So we're saying if this happens, and that's why we call it the intersection. It's where the graph of the compound inequality contains the intersection of the two solutions. Okay, so let's look at this: x greater than or equal to -4. So the graph does, if you see right here, it's a solid dot to the right. X less than 3 is an open circle this way. Where do they intersect? Between these red lines, and that is the intersection of those two. Now, compound inequality with the word and can be written two different ways, as one continuous or two separate ones. So let's look straight at example 1. It says, let's solve this inequality. So let's go here and let's look at what that looks like. So we have 8 less than 3y minus 7 less than or equal to 23. There are two methods. We can use the one method which has them both together. So I'm going to rewrite this. Okay, so we cover up, cut this piece off here. Well, let's just do it as one. We actually have two. So we have 3 sections instead of 2, like we're normally used to see, how it normally is and we're used to seeing. So we have to apply our properties. So if we add 7 to this middle section, we must add 7 over here and 7 over here. So then we have 15 less than 3y less than or equal to 30. So we're still solving for y, so we have to divide by 3 to get rid of this y here. So when we do it here, we have to do it here, and we have to do it here. So then we have 5 less than y less than or equal to 10. That is your solution. Now let's look at the other way. So the other way is we break this down to 2. So 8 less than 3y minus 7. Remember, it's an and when we have the less than, and 3y minus 7 less than or equal to 23. So this middle section goes with both sides. So you cut it off here and you got the left side. You cut it off here and you got everything to the right. So now we solve this pretty simple, right? So let's try another color here. So we're going to add 7 to both sides. We have 15 less than 3y. Divide by 3, divide by 3, and we get 5 less than y. I'm going to flip this to say y greater than 5. Here we're going to add 7, 3y less than or equal to 30. Divide by 3, y less than or equal to 10. So now let's go graph both of these. So we said 5 and 10. So we want y greater than 5. Y less than or equal to 10. And where do they intersect? Between here and here. And because it's open, it's just a less than, and this is less than or equal to. And isn't that what we have over here? So that's how you would graph it. So your graph would be the intersection. So you would graph it like this. Okay? So now you pause and you do the guided practice 1A and 1B. All right, so now we're going to talk about our other vocabulary, which is union. Oopsie, too far. Okay, so which is or. So union is going to be U, the symbol U. Intersection, I failed to tell you, was this way. Okay, so union means if you have, it's the graph of a compound inequality containing the word or of the solution sets. So union is true if one or more of the inequalities are true. So let's look at the key concept box. And what does that say? So this is an or. So it says the solution is x greater than or equal to 5 or x less than -3. So here are the two graphs. So together, this is your solution. And it's an or. You see that they're disconnected, disjointed. They're not connected, where the ands were connected, and it fell between a range. Here, they're opposite. You have a choice. It's like choosing, do I want to wear tennis shoes or do I want to wear flip-flops? Okay? So let's look at example 2 and work through this one together. So it says solve and graph the solution set. So it says k plus 6 is less than -4, or 3k is greater than or equal to 14. Now, and you had two options. You write it as one continuous or two separate ones with the and in between. Or, because they're not connected, have to be separated. You cannot write them as one. If you try, you're going to get it wrong. So we solve inequality using the inequality properties, which are the same as properties of equalities, with the one exception that if you divide and multiply by negative, you flip the sign. So we have k less than -10, or we divide by 3, and we get k is greater than or equal to 4 2/3. So now I'm going to go to the number line, and I don't care if you just write these two numbers, 4 2/3, or you can write it 14/3. So here it's telling you k is less than -10. Here it's telling you k is greater than or equal to, so you're going to fill it in 4 2/3. So you have a choice. So this is the solution set on a graph. So pause it and do guided practice 2A and 2B. So now let's move to example 3. Okay, solve each inequality, graph the solution set on a number line. So we have to remember that when we say the absolute value is less than 3, we're saying it's plus or minus, it's 3 units from 0. So if I graph this, then the 0, and I say it's 3 units, it's less than 3 units. So if I go to 3 here, right? So that's one solution. The other solution is here, because it's less than 3 units away. Well, it's less than 3 units on both sides of 0. So our solution is from here to here, which is from -3 to +3, and everything in between. Okay, so you just learned, we just did an algebra lab on this. You can write it two ways. Okay, so the graph would look like this. Well, you can do it on there, or I like to do it this way. I'll accept both ways because this way is neater, it's easier to see where the solution set is, or you can actually do it on the graph like this. Okay, both are acceptable. But then you've got to put it in either set builder notation or interval notation. Set builder notation says x, that's the variable we have here, such that, because it was the absolute value of x is less than 3, such that -3 is less than x less than 3 with the brace. Or when we're talking about, I like interval notation, it's really easy. You just go to your graph and you've got what? Here to here. Because they're open circles, you have a parentheses. If you had a closed circle, you would use a bracket. Infinity, positive or negative, always uses parentheses. So interval notation would just simply -3, 3 with parentheses. Okay, so let's look at this other one. So that's when it's less than 3. Okay, so you'll see a pattern here in a second. Less than means an and. A greater than sign means an or. So we'll learn that in just a second. So absolute value of x is greater than 5. So we're saying the solution is more than 5 units away from 0. So that's going to be more than 5 units. It's going to be here. And more than 5 units away, which would be the other direction. Remember, it's more than 5 units away from 0. So this is your solution because it's not connected. It's an or. Okay. Now, so there's your graph. What is its set below notation? It's going to be x such that x is less than -5 or x is greater than 5. The book puts this first, then this one, and they flip them over. They write this as 5 less than x, which says the same thing, and this says -5 is greater than x. It says the same thing. I like to read from left to right, like my variable to be on the left side, and from smaller to greater. So these both work. Now, how would we write it in interval notation? Well, we've got our graph here. So what do we got going on? We have -infinity to -5. We have 5 to positive infinity. Oops. So there you go. So how would we write that? We'd say -infinity, comma, -5, because it's an open circle, it's a parenthesis. Infinity is always a circle. Or 5, and here you must put them in order from least to greatest, or it will be wrong. All right, pause it. I want you to try guided practice 3A, 3B, 3C, and 3D. Now that you've done those, let's look at this key concept box here. And this is where I say it's really important. We're going to see it soon. So we can solve. See, that was just, up here was just a variable less than or a variable greater than some number. Now we're going to actually solve because we're going to have equations. We're going to have expressions inside the absolute value. So when you have the absolute value greater than C, a greater than sign is always an or. So then you drop that, so it's what's inside the absolute value is greater than C, or what's inside the absolute value, you flip the sign to less than, and it's opposite. When you have the absolute value less than C, okay, they write it, it's going to be an and, which you can write it as one continuous. I would write it, the other option would say AX plus B. I like to just do it the way it is, less than C, and I take the absolute value, the expression inside there, I flip the inequality sign, and it's opposite. Okay, the book writes it like this, which is fine because remember it's an and, so you have the option of writing it as one continuous. I personally like this because it just keeps me in the same pattern and keeps it straight. I don't have to worry about thinking about it and going, oh, which one do I have? I know it's less than, so then it's going to be an and then I flip the inequality sign and it's opposite. It's that simple. It's easier, for me, visually it's easier to solve, but you might like this one and see that okay and not make a mistake. So use that one if you choose. Now let's look at example 4 here. So example 4 says solve the multi-step absolute value inequality and graph it on a number line. So we have the absolute value of 6y minus 5 is greater than or equal to 13. Okay, so first of all, the absolute value must be isolated, which it is. And it's a greater than sign, which means it's an or. So I'm going to have 6y minus 5 is greater than or equal to 13. Or 6y minus 5 is less than or equal to negative 13. Okay, so now, do we know how to solve this? Yes, we solve it like a normal inequality. Now remember, we have y instead of x, and that's okay. Greater than or equal to 18, y is greater than or equal to 3. Or we add 5, we get 6y is less than or equal to negative 8. We divide by 6, and I'm just using some basic algebra skills here. Whoops, sorry. This should say y less than or equal to negative 4/3, and I just simplified in my head. So you have two solutions here. So we go to the number line, and we've got negative 4/3, or negative 1 1/3, and 3. So we say y is greater than or equal to 3. So it's greater than or equal to, so we have a solid circle, and greater than goes this way. Y less than or equal to negative 4/3. So there's your graph. And then in set builder notation, we're going to have y such that y is less than or equal to negative 4/3, or y is greater than or equal to 3. If I want to do an interval notation, it'd be negative infinity to negative 4/3, because it's inclusive, it's a bracket, or that's inclusive, 3 comma positive infinity. Remember, infinity is always parentheses. So these are your two ways of writing your solution set. Here is your graph to your solution set. Okay, so I want you to pause it and do 4A and 4B guided practice. All right, we're back, and let's look at example 5. Let's look at word problems, because sometimes we have to use word problems. We can use those to solve an inequality, a real-world problem. So it says, Amanda is apartment hunting in a specific area. She discovers that the average monthly rent for a 2-bedroom apartment is $600, but the actual price could differ from the average as much as $225. So it could differ, so it could be plus or minus $225. So remember, we said that was we had the x minus c and the equality equal r. So we have the same thing going on here, except for we have an inequality. So we're going to let r be our average monthly rent. Okay, so A says write in absolute value to describe the situation. So we have $600 minus C is going to be less than or equal to. You're like, how do I know if it's a less than or equal to or greater than sign? Well, it says it could differ from the average as much as $225, which means no more than. At the top, 225. So when you're just writing some basic inequality signs, no more than is a less than sign, or less than or equal to. Okay, so there's your inequality. Now it says solve it and find the average monthly rent. So we're going to solve for C. So I'm going to take, since it's isolate, 600 minus C less than or equal. This is why I do it this way. The book does a little bit different. I like to just stick with my same pattern. Once it's isolated, I write it. Because it's a less than, I know it's going to be an and. And then I take the expression in the absolute value. I flip the sign and I change it to its opposite. Now, all we have to do is what? Solve. And we can't forget how to solve. Remember, this is negative C less than or equal to negative 375. Divide by negative, what happens? You flip the sign. Okay, then we do here minus 600, minus 600. You get negative C greater than or equal to negative 825. Divide by negative C, you flip the sign, 825. And remember, it's an and we verify that when we actually go to graph it. So here's our graph. So 375 and 825. So it says here, C is greater than or equal to 375, and C is less than or equal to 825. So remember, we know they have to be connected because it's an and it is. So there's your graph, and then you can write it as 375 inclusive, comma, 825. In set builder notation, we can say C such that 375 is less than or equal to C, less than or equal to 825. So you choose which format. All right, stop the video. We'll see you in class.